Hello, this is Jim McKeeth, developer evangelist and engineer for Embarcadero Technologies, and welcome to this Delphi Developer Skills Sprint for Tuesday, the 16th of February, 2016 on effective if-def usage for cross-platform development. Because this is cross-platform development, it works everywhere, all the platforms and all the languages that you might be using today. A few things we're going to talk about. You'll also notice we're talking about platform services, which are not if-defs. They're not related to if-defs, but chances are there's some things that you may be thinking you need to use if-defs for that would be better suited to platform services. We're also going to look at some examples from the FireMonkey framework and the RTL, and then finally we're going to wrap it up with some best usage strategies. Not that long ago, there was one Delphi compiler, and it compiled for Win32, and that was all there was in the world, and we were happy. Today, the world is a much more complicated place. We have two different desktops or laptop platforms, Windows and OS X. And on Windows, we have both 32-bit and 64-bit. And then we have mobile devices, Android and iOS, with compilers for them. You'll notice there's three compilers for iOS. There's the 32-bit and 64-bit compiler for the actual and iPhone hardware. But there's also the simulator compiler. The reason for that is the iPhone simulator is not an emulator. Now on Android, the software version of the hardware is an emulator. It emulates the hardware and the software. On iOS, though, the simulator actually just simulates the software, but it runs on the x86 core, the CPU of your computer. There's no hardware abstraction layer in there, if you will. So that means that in order to run in the iOS simulator, there's a separate compiler which compiles for x86, but still compiles against the iOS libraries. Okay, so just something to keep in mind there, that there is that third separate compiler in there that you may not be aware of. So grand total, we have 7 compilers today that target all the platforms you want to target. And also I pointed out that the Android compiler is the DCC ARM, Android ARM compiler. And while it is a compiler for ARM Android, it also works on x86 Android via libhoudini. x86 isn't officially supported, but it does work. We've tested it. It seems to work. We've talked with Intel, who makes libhoudini, and they've made some fixes. Libhoudini was added in Android KitKat, so if it's KitKat or newer, you can use libhoudini to target x86. You just have to use it and disable the checks for it. So there's more information about that elsewhere. So let's talk about the FireMonkey platform services. The platform services is a you see the T platform services. You can use platform services to determine if features or functionality are available or on a certain platform. Okay, or the runtime for that platform. So you can discover it right here, tplatformservices.supports platform service, and check to see if things exist, like for example, keyboards or clipboards or whatever it happens to be. Then you can access the specific features with tplatformservices.getPlatformService. Now, two things. First of all, this is what's used a lot of places behind the scenes in the FireMonkey framework for it to work across all the platforms. But also, let's say you have some code that compiles across all platforms, but you don't know if certain functionality exists on certain platforms. That's when you can use platform services. So you can get a list of all the platform services there at that short link you see, embt.co/platform-services, and see what the platform services are. And then you can check to see if those services are available on the platform you're running on, and then use that to determine if you should execute certain code. Okay, so this is a higher level way than using if-defs in order to check for functionality. And it also gives you more granularity, things that you wouldn't be able to get access to check for from if-defs. So very important to understand how to use platform services. And you can actually replace the built-in services with your own implementation if you want to change functionality around. So that's worth looking at as well. So conditional compilation is the use of if-def or if-compiler directives and their associated directives to optionally compile selective branches of code. So with if-def, you can say, if I'm compiling for Windows, compile this code. Otherwise, if I'm compiling for OS X, compile this code. And those two branches of code are exclusive. If it's Windows, only the Windows branch of code gets compiled. If it's OS X, only the OS X branch of code gets compiled. So this is important if you are, especially if you're compiling against or linking in a certain platform API. So you plain can't compile the Windows code on OS X because the OS X does not have the libraries you need. So that's when you'd want to use if-defs, conditional compilation. One note about if-defs and conditional compilation is using it too much and sprinkling it out throughout your code really introduces a lot of complexity to code. So we're going to talk about some best practices in order to avoid that later on. So there's a number of predefined conditionals that are available to you to test for your code. So there's a list of some of them there on the right. The full list is available at that short link there. These are set by the compiler. So if you're using the Android compiler, then it sets CPU ARM, you see there, is set on the Android compiler, the iOS ARM compiler, and the iOS ARM64 compiler. So you can use these compiler directives to determine compiler features, CPU architecture, whether it's 64-bit, 32-bit, etc. One note is you can compile with the 32-bit compiler and then run on the 64-bit platform. So it's important to know that if you compile with 32-bit compiler and then you check for CPU 64 bits, it'll say no, even if you're running on a 64-bit platform. Okay, so then that's because you're using a 32-bit compiler, so you're going to have everything is 32 bits. You can check out all the conditional defines there at the link you see there, and also you can define your own symbols as well and check against those. So how does the RTL and FireMonkey framework use conditional compilations? And I'm looking at three specific examples here, and pretty much universally, the way it works is there is a high-level unit. So in this case, we have FireMonkey fmx.memo or fmx.webbrowser or system.notification. And then this high-level unit implements the common behaviors, the interfaces, the base classes, etc. And then in the implementation section's uses clause, there will be some if-defs to link in specific implementations for certain platforms. So, for example, for the memo, it links in either the fmx.memo.ios or fmx.memo.win, depending on which platform it's compiling for. Then within that platform-specific implementation, it implements the behaviors and links against the libraries that are specific for that platform. Okay, so in your code, as a developer, you use system.notification or fmx.webbrowser. Okay, you don't have to be aware of what that unit uses beyond there. So the advantages of this is your implementation code doesn't have to be aware of the different platforms, and you don't have all these if-defs sprinkled all over the place. Imagine if you had a method that had 4 different implementations in it, each if-def'd out. That would be a pain to deal with. This way you have one source file specific to each platform. So some best usage strategies. First of all, use platform services when possible. Be familiar with these, see what they offer, and when it makes sense, this is what you should be using. But if you're going to have conditional confines, which you probably will, keep those conditional confines in library code. Don't have them in your code that is tied to your current specific implementation. So if you're implementing a point of sale system, don't have any code related to certain platforms that would be if-def'd out in the code related to point of sale. Okay, so let's say you have your point of sale system uses a barcode scanner. So the barcode scanner, you'd have a barcode scanner unit, and then that barcode scanner unit would have if-defs to link in the different informations for the different platforms. So the Android implementation maybe would support hardware barcode scanners that are connected in through an accessory port, whereas the iOS barcode scanner always uses the camera, and then the Windows barcode scanner uses one that connects in through USB as a keyboard input, for example. So the software at the implementation of the point of sale system that shouldn't be complicated with the different implementations of the barcode scanner. That should all be abstracted out and separated out so that only the barcode scanner code links into the different versions. Typically, you're not going to want to mix like iOS and Android code within the same unit. Keep those in their own units, and that makes it a whole lot easier to deal with. Because once you put it in the same unit, then you have to have lots of if-defs, and keeping it in the uses clause limits the number of if-defs. Also, you might find it useful to create a unit with useful constants. So if you have some constants that are going to change from platform to platform, for example. Put all that in a unit and define those constants and have the if-defs in there. So let's look at a few examples and demonstrations here. So what we have here are just some unit tests I've created to show the different conditional compilation options you have. So this one here's an if-def Windows. You can actually do if not def as well. And now this will fail because it says it's not Windows because I tested against Windows, but we want it to pass. So the else statement is optional here. You don't have to include an else, but you do have to end every if-def with an end if. Okay, so that's if-def syntax. You can also do the if syntax. This is a newer feature, was added, I don't remember when this was added, but added a while ago, that lets you use if. And you can say if defined MS Windows. So instead of if def Windows, MS Windows, you say if defined MS Windows. But the cool thing is you can do and in here, and you can check the value of constants. So you can say compiler version equals 30, which is the version for Seattle. So if both those are true, then we're on Seattle for Windows. Again, you can have an else, that's optional. And then an if is ended with an if end. Now, if can also be ended with an end if. All right, there's a compiler directive there if you want to say, I only want to end it with an if end. I'd never want it to be ended with an end if. And that allows for nesting and different creative things. Generally, it's not a big deal, but you can end it either way. And again, the else is optional on both of these. So here we see an if statement where it's checking compiler version, RTL version, and FireMonkey version. One note is FireMonkey version is defined in FMX types, so you have to make sure you use FMX types. And this is what's the versions of these for 10 Seattle. If you wanted to check to see if it was 10 Seattle or newer, then you could say greater than equal to on any of these. And this would check to see if it was 10 Seattle or newer. So if's a lot more flexible than the if-def. It really depends on what you're testing for. If you're just testing for one of these compiler directives like platform, CPU architecture, etc., then you want to probably use just if-def. But you can, like I said, use defined there as well. Now these tests here show how to use platform services. Platform services is defined in FMX platform, and each of these different services are defined in a different unit as well. In this case, the clipboard service is defined in FMX platform. If you want a full list of it, check out the short URL, which I'll show you in the learning resources. It has the full list and what units they're defined in. So we have two different ways you can do this. I'm calling this the long way. Here you can just check. So you just check to see if it is by calling platform services. You want the current platform, supports platform service, and you want to pass in the name of the service you want to check for, the interface for it. And that will return either true or false. If it's true, then this code will only execute when the service is supported. Now, the difference between platform services and compiler directives is this code will always be compiled in. Okay, so you don't want to use platform services to try and prevent code from being compiled like a conditional compilation would. Instead, this is only code that's going to execute when, in this case, the clipboard service is available. Now, I call this the long way because now we can get an instance of the clipboard service by calling platform services current get platform service and the name of the service we want, and then we cast it. Now we have a clipboard service. We can set the clipboard and get the clipboard value from here, and then we just test to make sure that it actually worked correctly. If we didn't have clipboard service, then it would raise us an error here. So this is the short way here. And this time, all we do is say supports clipboard or supports platform services, and then we pass in the variable we want to have the instance to. And so this just basically has the call to get platform services here and returns it as that one there. And so now we can just access the clipboard to set the value and then to get the value from it. That's it. That's all there is for platform services. You can check out the documentation if you want to look at how to add your own platform service, remove existing platform services, etc. But this is the most common scenario you're going to use is look at the platform services to see if a certain feature is supported and then access that service in order to interact with it. So we're going to look at a couple examples here, one in the RTL and one in the FireMonkey framework. And you'll see this pattern continues throughout all of the FireMonkey framework and RTL. So this is system.notification. So if you wanted to include notifications, you would use system.notification. Now, if we jump down to the implementation uses clause, you'll see right here we have if-defs here. So if-def iOS, use system.ios.notification. These are the only if-defs in here. That's it. No other if-defs. Okay, so there's not if-defs sprinkled throughout the file, making the file more complicated. They're only here in the uses clause. Now, the system.notification implements the base classes, interfaces, common behavior, etc. So if we look at system.mac.notifications, in here, we see that it implements the T Platform Notification Center which is based on the T Base Notification Center. If we jump back into our system.notification and look for Platform Notification Center, we'll see right here in the internal get instance is when it gets an instance of that. Okay, so this is how the system.notification implements the platform-specific implementation. Now we looked at the Mac version and the Android version. We're seeing exactly the same pattern here. So now let's look at FireMonkey's T web browser. Again, we have a fmx.web browser. If we jump down to the implementation uses clause, we'll see some if-defs in here. Now this is using both if-def and if-defined. And again, this is the only conditional compilation in here is in this uses clause. And here, if it's Android, we're going to use webbrowser.android or webbrowser.cocoa. So if it's iOS or Mac OS 10, it uses webbrowser.cocoa. So we can take a look at those implementations here. And what they do on this pattern is it registers a platform service. So register web browser service adds a platform service. And that's once that service is added by webbrowser.android, then fmx.webbrowser is able to implement that service, what that service implements, or it's able to use that service, I guess. We'll take a look at Cocoa, the exact same thing here. Register web browser service. So some of the advantages of this is if you have somebody on your team that knows Cocoa really well, they implement the webbrowser.cocoa, and someone that knows Android really well implements the webbrowser.android. It keeps that separate. When something changes on Android, you only change the .android implementation. So it has a nice separation. Again, very few conditional compilations, only right here in the uses clause are the only place to see them. For more information, some of those first two links we've seen before in the code earlier, but then we also have some see also slides here on the if directive, which is a newer option for conditional compilation as compared to the if-def. You also can check out the list of compiler versions, compiler directives for library shared objects, which is great if you're creating some code you want to share with others, or just code that you're going to have library code for. And then also the complete list of compiler directives. And as we just did, look at the source. So the way FireMonkey and RTL is implemented is a great example of best practices for doing this. So you can find the source for Tin Seattle in that folder there, assuming you use the default installation locations. Give me a brief moment to tell you about this limited time special offer. All Tin Seattle registered users get the bonus pack, which includes the new Object Pascal Handbook by Marco Cantu. This essential language reference is a modern language guide that includes new features of the language and the core runtime library, a must-have for any Delphi developer. Also get the Binder Converter Basic. It handles the heavy lifting when converting existing VCL applications into FireMonkey applications, so you can start taking advantage of multi-device development right away. And the Premium Style Pack includes premium styles for VCL and FireMonkey to make your application look great on every platform. For more information on these special offers, or to find out what the current offers are, please visit www.embarcadero.com/radoffer. And one more special offer we have only for the month of February is if you buy one tool, you get another tool for free. And it's a tool of equal or lesser price. The website says value, but sometimes you feel like you're getting better value on the free tool. It feels like sometimes, at least for me. So if you buy Rad Studio, Delphi, or C++ Builder 10 Seattle, either new user or upgrade, Professional Enterprise Ultimate Architect, you can get any of those tools you see there. For example, Konopka Signature VCL controls, CodeSite Studio 5, Interbase, or a number of the other database tools. Full details and instructions are available at the RAD offer page you see down there at the bottom. So check that out. If you don't have 10 Seattle yet, this is a great time to upgrade to 10 Seattle and take advantage of the special offer. Next time, we're going to have a skill sprint on using FireMonkey T-image lists effectively. This will be on Tuesday, the 23rd of February and Thursday, the 25th of February, 2016. Delphi on Tuesday, C++ on Thursday. The times and dates of our sessions are based on San Francisco time, so use timeanddate.com or whatever mechanism you prefer to make sure that you show up at the right time with the right time zone changes and such. And now it's time for Q&A. So we have a few questions here. First one is it possible to hide code that is not satisfied by an if-def? So if you if-def for different platforms, hide the code that doesn't apply. So there is not an automatic way to do that. You can right-click on it and fold sections of code up. But if you follow the best practices like outlined in here and keep your if-defs just to your uses statement and have each unit focus only on one condition, then you're going to find yourself not needing to have if-def sprinkled throughout your code, and so you're not going to need to do that. So you're going to have less impact on your debugging because you have less if-defs, and your code will be easier to maintain. If you do find that there are instances you do need to have multiple conditions within a single file, make sure that is isolated in a certain library file. So it shouldn't be sprinkled out in your code that solves your business case. Question, why is there not a defined for compiler version? There is. It's called compiler version. I showed it there. Compiler version will be the current version. It used to be people would always have these version.include files that they would use that would say version, 2009 and up, version XE2 and up, or whatever. You don't need to do that anymore. If you just use the if compiler directive and say compiler version greater than or equal to 30, so 30 is Seattle. If you wanted to check for XE8, it would be, I think it was 29. Check out the link there for compiler versions and just say greater than or equal to that version or less than or equal to that version, and you can know exactly what version it is. No need to set up a version.include file. No need to update the version include file when a new version comes out, anything like that. It's all automatic just by evaluating compiler version greater than or equal to. Yeah, so there's a few requests here to have predefines for like certain versions and up. You don't need those anymore because you only need those if you're only using if-def. With the if compiler directive, you can compare the compiler version, or actually there's other versions there. There's compiler version and FireMonkey version, and what was other RTL version, which I showed all those there. So you only those old compiler directives you see people defining, you don't need those anymore. Just use if compiler directive. So there's a question here about the POSIX. POSIX is a family of operating systems that includes BSD, Unix, and Linux. OS X is based on BSD. iOS is based on OS X. Android is based on Linux. So all of those have the POSIX defined. So that's what those would mean. In the future, on the roadmap, you saw that we have Linux planned for the future release. So Linux is also in the POSIX family, so it would also have POSIX defined. Okay, thanks to everyone for joining us and for all your questions. You're welcome. Lots of good thank yous for the new ways of using it. A lot of people have been using if-def. Excited to be using ifs instead. So yeah, if's much more powerful when you're trying to define if it's a certain version or newer, or evaluate multiple definitions in the same check. So David's asking, if 10 Seattle version number is 30, how do we know the actual version number versus the marketing version number? So that's a really good question. 10 Seattle it's version 10 Seattle, and then the next release will be version 10.1 with a different city name, 10.2 with a different city name. But the compiler version can be found in the doc wiki at the URL I provided for you there. And you'll see that it has the conditional, which is VER 300 for Seattle, if you take the first two digits of the number 30, that's the compiler version. So version 29 was XE8, or which is VER 290. Take the 29 out, version 29. There's a few different version numbers. There's a reason for that, I'm sure. But yeah, it's a little confusing, but you just look at that list there and you can find what you're looking for. So what's the difference between Mac OS and OS 10? So from Apple's point of view, historically, the OS for their desktop was Mac OS. And they then with the version, so that OS 9, Mac OS 9, and then when the next version came out, OS 10, which was the one based on BSD, which I can't remember if they went to x86 processor in OS 9. I think they did. And then OS 10 was x86 only. They started calling it OS 10, which is OS X, Roman numeral 10. So Mac OS and OS 10. OS 10 is the version specific, whereas Mac OS is the more generic term. So it'd be like saying Windows versus Windows 10. Okay, so OS 10 is Windows 10. It's the specific version, which all versions since version 10 have been called OS 10. It's OS 10.1, OS 10.2, OS 10.3, and then with Windows 10, it's when each version of Windows after that's going to be called Windows 10 as well. There's going to be incremental upgrades. So the compiler directive, though, is Mac OS. That's the compiler directive, or compiler conditional defined that we look for to determine if we're compiling for the Mac OS. So Wade's asking the if directive supports and, says assuming it supports other logic like or, etc. Let me look real quick. I think that is correct. I believe that is correct. I haven't tested that. I'm looking at the DocWiki page for it right now, and I don't see anything that says one way or the other on that. So it would be easy enough to test that really quick and find out for sure, Wade. I believe it works with any statement that you could do that would be could be defined as to a Boolean. So and or it does have the same rules about parentheses. So if you say this equals this and that equals that, remember operator priority has the and executing first, so I'm going to put parentheses around the individual equal statements. It says when I use ifdef Mac OS and compile for iOS, the Mac OS segment is included. I've had to do something like if not iOS, Mac OS. Am I not understanding something? Okay, so that's a really good question. And if you look at the chart, which is in the list of conditional defines, which I have a little segment of that there. But if you go take a look at the conditional compilation short link that was, so if you go to that list there, you'll see that Mac OS is defined on DCC iOS ARM and all the DCC iOS ones. The reason is because iOS is actually based on Mac OS. Okay, so the way you can check to see if it is Mac OS and not iOS, yeah, you would have to do like you're checking. So instead of doing a nested if def with an if not def, do if defined iOS and not defined Mac OS. Or I'm sorry, the way around. If not defined iOS and defined Mac OS, then you would be correct. So I understand why you would assume that Mac OS would be the desktop, but because Apple based iOS on Mac OS, technically iOS is also Mac OS, which seems weird to me, especially because you can't run a Mac OS app on iOS or vice versa. So, but yeah, that's the way it works. So you would have to check for that it is Mac OS and not iOS to make sure you're on the right spot. What is the meaning of implicit building conditional define in package source code? Let me look at the DocWiki on that. Because I don't remember exactly what this is. I remember looking at it before, but I don't remember exactly what it is. Let's see. Implicit build. So it says that when implicit build is set to off on a package, it prevents the source file in which it occurs from being implicitly recompiled later. So you use implicit build off in package source files when the compiling packages that produce low-level functionality that change infrequently between builds or whose source code will not be distributed later. So the idea is that when you have a source file that isn't frequently changed, you can turn that off until it is implicitly built. Then that's the only time that particular source file will be rebuilt later. Hopefully that answers your question. I have source code part of a purchase package for a very expensive third-party component that I can no longer afford support for. Is there anywhere to go that could give me tips on how to update it for more modern Delphi? So Neil, it's hard to say for sure without more information, but one thing is it's probably using the old-fashioned way of explicitly defining compiler versions it works with. And the problem with that is that when a new version of the compiler comes out, it doesn't know how to do that. So it's saying if def version this, if def version this, if def version this, instead of using the if compiler version is greater than or equal to this. So the first thing you'll need to do is find out, let's say it was built for XE8 and you're on 10 Seattle. So you're going to find where it's checking the if def XE8 and change that to also check for 10 Seattle, or change it to compiler version 29 or greater. And then what that'll do is that will allow the compilation path to compile, because Delphi's got really good backwards compatibility. That would be the first thing you need to do. The second thing you need to do is then, once you've done that, go through and find out where is it not compiling someplace, is it not running someplace, and just address those individual concerns one at a time as they come up. But the first thing you need to do is fix that, because it's most likely using if def ver 2800 or whatever it is, or whatever version of Delphi it was originally written for. And so it doesn't understand that 10 Seattle is newer because it's not written with the correct if conditional compile or conditional compilation. So a great way to test it without knowing more about what the library does is to create unit tests around all the functionality in the library. There's documentation about unit tests. We have some videos about unit tests as well. And just go through and run those unit tests, or create unit tests around the functionality you want to use, and to make sure it works correctly. And so once you've done that, you create the unit tests around what you want to use. If they pass, it's good. If they don't pass, then you go and fix it until the unit test passes. And then that's a way to know that it's working. And then as you're maintaining it in the future, let's say when 10.1, whatever city that's called, comes out, and you need to make sure it's going to work with that version, you just run the unit tests again, and that will go through and give you green light, yes, it all still works, or no, you need to change what's failing, and it'll tell you what's failing. So creating unit tests is a great way to make sure that your library is working as expected. Scott's asking for the feature matrix, and I'm assuming that was the list of compiler predefines, which is available at embt.co/sprint-ifdef. We'll bring you to this page here. The link is in the chat window as well. And from here, you can get a list of predefined conditionals. Go to this link here, and they'll give you a list of all the predefined conditionals that the different compilers have. So you have a grid similar to the one I showed that has the compilers across the top, and then the different predefined conditionals down the side, and then which platform they show up on. So as far as the list of platform services, that's also available here from this page here. If you want to get a list of all the different platform services that are available, it would be right here. Go to the embt.co/platform-services, and that will give you a list of all the different platform services, along with the unit the platform service is defined in. Question about Linux compiler. Linux compiler, you can check out the roadmap, which I pasted in there. You can also just go to the community.embarcadero.com, and you can find a link to a roadmap right there on the front page. And the current plan, according to the roadmap, is that after the next release, which is codenamed Big Ben, there will be a preview release, probably for people on update subscription, that will include Linux compiler for Delphi. And then in the Godzilla release, which is later this year, towards the end of the year, will include the Linux compiler. So if you want to get in on the preview, definitely get in on update subscription. What is the best way to handle if-defs with breaking changes between versions? So it really depends on what it is you're trying to accomplish. If you're wanting to maintain compatibility between the two versions, Delphi, I said Delphi 2 and Delphi 6, then you probably just want to use the if directive. So if compiler version is greater than this or less than this, or whatever it is you're trying to isolate down, then perform this one, otherwise perform this one. Really, though, I would encourage you to take out and isolate that in a separate file. You don't want, basically you want to have your if-defs in as little spread out as possible and as few as possible. And so if you can set up a file that contains a function call, and then that function call either behaves one way or the other or something along those lines, and then use that instead of what's changed, that's the best. So whatever you can do to isolate your if-defs and prevent them from being spread throughout your code is really going to improve the maintainability of the code. Or I guess your if compiler directives. Those are really, when you're dealing with compiler versions, don't use if-defs. Use if compiler version greater than equal to whatever you're trying to target. Great to hear that you've been enjoying your update subscription, Walter. That's good to hear. I think we are about done. Thanks so much for joining us. Let you know that Thursday we're going to have our C++ skill sprint on if-defs, well, ifs and if-defs, basically conditional compilation. And then next week we have using FireMonkey T image lists effectively. So 2 effective skill sprints in a row.